In this video, we're going to go over common misconceptions with this unit and also a little bit of a review. So to start, elements are the basic building blocks for our rocks and minerals. Examples of elements could be carbon, oxygen, lead, and sodium, and each of them has a specific chemical symbol. On the bottom of page 16 of the reference table, you have all of the chemical symbols of elements that you need to know for this particular unit. Elements are what make up minerals. So for an example, mineral halite contains the elements of NaCl, which is sodium, and chlorine. Another example is the mineral galena that contains the elements of lead, which is represented by Pb, and sulfur, which is represented by the letter S. Finally, minerals are what make up rocks. So in short, elements make up minerals, and minerals make up rocks. So some examples of that could be the rock salt, which contains the mineral halite, which contains the elements of sodium and chlorine. Another example could be the rock limestone that contains the mineral calcite, which contains the elements of calcium, carbon, and oxygen. Now, a brief review for igneous rocks. We're going to use the rock granite as an example. To find information about the rock granite in the top part of the chart, you can take granite and move it over to the left side where you have environment of formation. Granite is in the intrusive section, which means granite formed inside of the earth and it cooled very slowly while forming. If you take granite and you also bring it over to the right side of the chart, underneath the crystal size column, you'll see that you have crystals between 1 to 10 millimeters. The texture is coarse, and the texture is also non-vesicular, which means the rock does not have any gas pockets. Since granite is intrusive and it cooled so slowly, it has relatively large crystals, which gives it that coarse texture. Also get information from the middle part of the chart. If you take granite and you bring it down to the middle, you can get information on the color, which is a light color, density, which is low density, and composition, which is felsic. Any felsic rock is going to have a light color and a low density. Also, below the word felsic in parentheses, you'll see that any rock that is felsic is going to be rich in silicon and aluminum, and those are elements that are found within the minerals inside felsic igneous rocks. Finally, you can get some more information about the minerals within granite if you bring it down to the bottom part of the chart. Granite actually has 5 major minerals in them, which are all listed on the screen. So in summary, this rock granite is made up of minerals, which are also made up of elements. Now to review sedimentary rock identification on page 7 of your reference table, the first thing we want to focus in on is the top part of the chart, where you can see that you can have rocks at the top that are clastic in texture, and that's your clue that all of these rocks formed from the processes of compaction and cementation. All of these rocks are made up of different sized sediments, which you can see in the green size column of the reference table. Shale is a sedimentary rock that is made up of the sediment clay. Sandstone is a sedimentary rock that is made up of the sediment sand. All of these rocks had their sediments compacted and cemented together in order to form the rock. On the bottom part of the chart, you have 2 more types of sedimentary rocks. The first that we're going to talk about are the chemical rocks, which are the top 3 in the chart, which can form from evaporation or precipitation of water. All of these rocks form in a very similar way, and they're called chemical sedimentary rocks. You can read the comments column to figure out how these rocks are specifically formed. The bottom 2 rocks, you can also read the comments section to figure out how these rocks formed. These are organic sedimentary rocks. Specifically, bituminous coal forms from compacted plant remains, and the rock limestone can actually be both chemical and organic. Now that's something that's been confusing us, and we can tell that by looking at the texture column. Limestone can either be crystalline in texture, which refers to chemical sedimentary rocks, or it can be bioclastic, which refers to organic sedimentary rocks. So limestone can be both. Finally, in this unit, we learned about metamorphic rocks, and there's two main types of metamorphism. The top part of the chart is reserved specifically for regional metamorphism. That's when, as you go deeper into the earth, heat and pressure increases, which causes the rocks to change into metamorphic. If you look at the texture column, the texture of regional metamorphic rocks are all something called foliated. And foliated means it looks like the rock has layers. Now, foliated can be broken up into two parts: mineral alignment and banding. So you can be foliated and be either one, mineral alignment or banding. Remember that the composition column always tells you what the rock is specifically made up of, and in this case, it's the minerals in the rock. This next slide is showing you how regional metamorphism works. It all starts with sedimentary rock shale. Now, shale is not a metamorphic rock, it's sedimentary, but if shale is put under heat and pressure, shale turns into metamorphic rock slate. If you go deeper into the earth with more heat and pressure, slate turns into a rock called phyllite. More heat and pressure, phyllite turns into metamorphic rock schist, and even more heat and pressure, schist turns into a metamorphic rock called gneiss. Finally, the bottom part of the chart talks about rocks that have both regional and contact metamorphism. Now, to start, I want to make sure that we understand again in the composition column, you can find the minerals or the ingredients that make up the rock. And all of the rocks at the bottom part of the chart are non-foliated. So this means it doesn't look like these rocks have layers. Now, I want to be able to talk to you guys a little bit more about contact metamorphism. So here's a diagram that looks like something you've seen before. It has different layers of different sedimentary rocks. So this illustration is going to show you what each layer is made up of. So layers A and D are both made up of limestone, B is sandstone, and layer C is shale. And I know that by looking at the map symbols on page 7 of the reference table. What happens sometimes is that magma from deep inside the earth can hit rock that was already in existence, and we can call that an igneous intrusion. When that happens, all the heat from the magma is going to turn that rock that already existed into a metamorphic rock, and that is called contact metamorphism. Anywhere you see highlighted in red is along the contact zone. That is the place where the lava or magma was hitting the pre-existing rock. Now, there's not contact everywhere. The magma did not hit every single part of the rocks that were already there. It only hit a small part, which is represented by the contact zone. You only get metamorphic rocks to form at the contact zone. So anywhere where you see the red is where you're going to have metamorphic rocks forming, only where there is contact. Now, how do we know what metamorphic rocks will form? Well, in both rock layer A and also in rock layer D, limestone was there. At the contact zones only, where the contact zone hits the limestone, that limestone is going to turn into metamorphic rock called marble. Now, how can we determine that? If you look on the reference table for the metamorphic rock diagram, you'll see in the comments column, that's where you're going to get your information. In the comments column, it tells you if you have metamorphism of limestone or dolostone, you're going to result in a rock called marble. Just above that, if you get metamorphism of sandstone, you'll get the result of metamorphic rock quartzite. So I now just want to take the time to go over some example questions that you might see on Castle Learning that could be a little bit difficult at first because it requires a lot of searching. Sometimes rock and mineral questions aren't hard, they just require a lot of time and patience for you to find the answer, and I never want you to give up on yourself. So one example here is, which two rocks usually consist of only one mineral, but may contain additional minerals? So in your answer choices, you have all different kinds of rocks that range from sedimentary, igneous to metamorphic, and you need to go through each of the diagrams in the reference table to see what minerals make up each of these rocks. Your goal is to find the rocks that only have one mineral. So the answer to this ultimately is quartzite and dunite. And again, you have to look up each rock on page 6 or 7 of the reference table and look at the minerals in those rocks to figure out which of these rocks have one mineral. Yes, this is going to be time consuming, but ultimately you can definitely find the answer. You just have to put a little work into it. Another example of a question that seems hard, but if you put in the work, you'll get the answer, is which mineral can be found in the rocks phyllite, sandstone, and granite? You have to go through the reference table and you need to look up all 3 of these rocks. You have to look up phyllite, sandstone, and granite, look in their compositions to see what minerals are made up of them, and then you can see that all 3 of them have one mineral in common, which is quartz, which should be your answer. Again, the answer is in the reference table. It just requires a little bit of work to get it. Finally, this question also requires a little bit of work, but once again, very easy to get the answer. Which rock is composed of a mineral that can be used for the production of cement? So the first thing you need to do is figure out what mineral can be used for cement, and then you have to find which rock has that mineral. It's a 2-step process. The key to this question is that they're asking for the use of a mineral. If you go to page 16 of the reference table, there's a whole uses column. You find the mineral that's used for cement, which is calcite, and then you have to figure out which rock has that mineral, which is going to be limestone. Good luck with your review, and please reach out if you have any questions.